Let us write down the definition. Let us talk about the definition of concave up and concave down. Let fx be a differentiable function on an interval, open interval I. The graph of f is concave upward on I if f prime of x is increasing and concave downward if it is decreasing. Okay, so f prime of x, look at this. This is the first derivative, right? First derivative is increasing in the interval -1 to 1, right? It is increasing in this interval. And then it is decreasing on those two intervals, right? So decreasing means concave down. In the region when it is concave down, it is decreasing. Look at that. In the region when it is concave up, then the first derivative is increasing. That's what it is saying. The graph of f is concave upward on I if the first derivative is increasing. That is that region. In that region, it is concave up. And it is concave down if the first derivative is decreasing. So we don't check with the first derivative, we will check with the second derivative. Okay, to check the concave up and concave down, we will use the second derivative. Let's read this one. Let f be a function whose second derivative exists on an interval I, open interval I, if the second derivative is positive for all x in that interval, then the graph of f is concave up. Whenever there is concave up, then chance of minima, local minima, right? Okay, we'll talk about that later too. If the second derivative is negative, that's the second derivative is negative. That is the second derivative negative, this region, and that region is second derivative negative, meaning whenever the first derivative is decreasing, then second derivative is negative, right? In that region, it is concave down. Concave down means local maxima. Whenever it is concave down, there is a chance of having the local maxima. What is needed there is second derivative negative for the local maxima or concave down. Second derivative positive means local minima or concave up. Okay, how about the point of inflection? Boundary points between concave up and concave down are called the point of inflection. At the point of inflection, either the second derivative is 0. Look at this. Second derivative is 0 here, right? Second derivative is 0 here. What is that point? -1 and +1. -1 and +1. See? Did you see that? That point and then that point are the point of inflection. They are the boundary between the concave down and concave up. Concave up and concave down. That's the boundary, right? These are the point of inflection there. In the point of inflection, how do I find out using the second derivative? Is in the point of inflection, it can be either the second derivative can be is 0 or the second derivative is undefined. Okay, so that's what happens. But sometimes we will have to do increasing and decreasing just to make sure that sometimes we will see undecided form. Okay, no local max, no local mean form, and then you will have to do the graphing. So we will consider that type of example. But let us talk about steps to find out concavity and convexity, or concave up and concave down, also the point of inflection. How do I do? What are the steps? If a function is given like this, what we do is first find out f prime and f double prime. After you do that, find the numbers where f double prime is 0 or not defined. We set f double prime equals to 0, and then we will also find out the points where the f double prime is not defined. After you do that, draw a line and mark those points you got from step 2 and find the signs using the test points. You remember finding the signs plus, 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 minus, minus, minus of f prime. Here we will find out the sign of f double prime, right? So sign of f double prime using the test points. If f double prime is positive, concave up, there is a chance of local minimum. And if f double prime is negative, then concave down, there is a chance of local maximum. If double prime is equals to 0 or undefined, there is a chance of point of inflection, just chance. Okay, not for sure, because sometimes you get some result that you will have to do the first derivative test. We will have to go back to first derivative test. Okay, we'll consider all those types of example here. Okay, let us do this example. Determine the concavity and the point of inflection for this this function. Okay, step 1 is find f prime. What is f prime? Is negative 15x to the 4, right, plus 15x to the square. Did you see that? Because what is the derivative of x to the 5? It is 5x to the 4. So 3 times 5 will be negative 15, right? Here also derivative of x cubed will be 3x square. So 5 times 3 is 15x square. Let me find out f double prime. So find the derivative of that. negative and let me choose this color, negative 60 x to the cubed plus 30x, right? Now set that equals to 0 because there is no point that f double prime is not defined. This is just a polynomial function, so it is defined everywhere. Now I want to solve for x. What do I get? Let's factor out negative 30x. What do you get? Negative, so whenever you take out negative 30x, what is left is 2x squared plus 1 equals to 0, right? Minus 1 because you are taking negative 30x, right? So it will be minus 1. Now I want to solve this, so that is minus 1, right? I want to solve this one. How do I solve this one? So how do I solve this one? So set that equals to 0, you will get. So if you set this equals to 0, you will get x equals to 0. And if you set that equals to 0, you will get 2x squared equals to 1, right? And this implies x squared equals to 1/2. So what is x? X will be plus minus 1/2, right? These are the points that where the second derivative is undefined or 0, right? Because there is nothing undefined. So how many points? X equals 0 is 1 point, x equals to plus 1 and minus 1. So minus 1/2, 0 plus 1/2, right? So we want to know whether it is where it is concave up and concave down. You see that? So how do I do that? Is I take a test points. I take a test point here. Let's take negative 1. I take a test point. Let's take negative 1/3. Take a test point. Let's take positive 1/3. And let us take positive 1. And then we will check the sign of f double prime. What is f double prime? F double prime is equals to you can plug in here or here, negative 60x cubed. Let me write down little above that so that I will have space. Okay, so the f double prime is equals to negative 60x cubed plus 30x. Okay, I want to know the sign at each of those test points, and I'll mark the sign there. Okay, so I want to know whether it is concave up or concave down at these points. Okay, so the first thing I want to do is I want to look at this section. Let's plug in negative 1 here. Negative 60 times negative 1 to the third is negative 1. So negative 60 times negative 1 is positive 60. And then plus 30 times negative 1 will be negative 30. 60 minus 30, it will be positive. The second derivative is positive here. So it is concave up, right? Let's plug in negative 1/3. So negative 1/3 will be negative 60 times negative 1/3 to the cube will be negative 1 over 27, right? So negative 60 times negative 1 over 27 will be positive 60 over 27. And this is 30 minus 1/3 will be 10, right? So it will be negative 10. This will be positive 60 over 27 will be almost 2 point something. So 10 minus, okay, this is minus 10. It is plus 2 point something will be negative. So this part is negative. So it will be concave down. You see that? So this part it is concave down. Next is at this point at 1/3, positive 1/3, what happens? Negative 60 times positive 1/3 will be negative 60 times 1 over 3 to the third is 1 over 27. So negative 60 over 27 plus 30 over 3. 30 times 1/3 will be 30 over 3. If you can use calculator just to plug in these values, I will get positive sign here. So it is concave up. And then if you plug in 1, negative 60 times 1 to the third is negative 60 times 1 is negative 60 plus 30 will be negative sign. So it is the concave down. Okay, so what do you think? So the concave up interval, so concave up is negative infinity to negative 1/2 And then what is the next one? Negative 1/2 to 0. Oh, sorry. 0 to 1/2. 0 to positive 1/2. That is the concave up. How about concave down? Is negative 1/2 to 0. And then 1/2 to positive infinity. These are the concave down because of the second derivative. Okay, guys. If there is a concave up, you see that if there is a concave up, there is a chance of local minima. There is a chance of local maxima. There is a chance of local minima. There is a chance of local maxima, but we haven't checked that. Okay. If there is a local max or local mean, there should be a concave up or down, but the concave up or down does not imply there must be a local mean or local max. Okay, so it does not imply that. But what we can say is this is the boundary. Negative 1/2 is the boundary between concave up and down, right? So it is point of inflection. This is also the boundary between concave down and concave up. This is another point of inflection. And this is also another point of inflection. These are the point of inflection. In the next example, we will dig more into finding the point of inflection.